Greetings from Mountain View, California. My name is Jim Bond. I'm the Senior Clinical Marketing and Education Manager here at Mindray Zonari Medical Systems. In this following video, I'm going to tell you the story of ZST, or Zone Sonography Technology, the core underlying technological foundation of a unique proprietary ultrasound imaging system. Zone sonography technology is a unique proprietary method of producing ultrasound images that is unparalleled in the sonographic imaging industry. ZST is made possible by patented engineering technologies and advanced software algorithms that provide the ability to see with ultrasound imaging structures within the human body that have never been seen before outside the surgery suite or the pathology laboratory. ZST provides the ability, in some instances, to identify sub-millimeter structures in temporally accurate real time. For example, in this case of normal renal vein valve cusps, seen opening and closing over the cardiorespiratory cycle. These thin, ephemeral anatomical structures, while present in about 19% of normal individuals, have never been reported before in the medical ultrasound literature prior to their demonstration with zone sonography technology. Similarly, sub-millimeter digital vein valves in this index finger can be clearly resolved in temporally accurate real time using an industry-leading 20 megahertz linear array probe. Again, structures never before seen with conventional ultrasound imaging technology. There are several fundamental differences between zone sonography technology and traditional beamforming ultrasound technology. First, beamforming technology is hardware-based and requires the integration of a large number of digital boards arranged within a large chassis. This conventional configuration creates a platform with a large footprint that is heavy, difficult to maneuver, particularly in tight clinical spaces, and generates a considerable amount of ambient heat. Upgrades to hardware-based platforms are expensive, time-consuming, frequently involve taking an ultrasound room down for the entire day, which results in patient and operator inconvenience, and also many times revenue is lost as the room is not in operation. Zone sonography technology is software-based. The hardware components necessary to run all of the imaging, workflow, and communications interfaces are housed within a quickly removable and easily replaceable 10-pound module that is seated on the front of the cart beneath the user interface. This innovative configuration permits the design of platforms with a small footprint that are lightweight and easy to maneuver even in the tightest and busiest clinical environments. Heat output from a ZST platform is about equivalent to that generated by a typical desktop computer. Upgrades to a ZST platform are achieved by uploading files from a simple USB flash drive. Usually requires less than an hour to accomplish, with minimal disruption of service and minimal inconvenience to patients and operators. The unique imaging capabilities of zone sonography technology are the product of what we refer to as the 4 pillars of ZST. These proprietary digital signal processing methods include advanced acoustic acquisition, dynamic pixel focusing, automated sound speed compensation, and total recall imaging. Advanced acoustic acquisition refers to the ability of a ZST ultrasound system to acquire very large amounts of raw acoustic data in a very short period of time. As demonstrated in this animation, traditional beamforming systems acquire and process acoustic data in a line-by-line fashion. Because of the time of flight limitations inherent in pulsed echo ultrasound imaging, this method of data acquisition imposes well-established temporal constraints on image acquisition and on signal processing capabilities. ZST, on the other hand, by utilizing multiple transducer crystals simultaneously on both transmit and receive, generates and acquires acoustic data in larger zones. Each full frame of imaging information is received and processed approximately 10 times faster than with traditional beamforming platforms. Another characteristic of advanced acoustic acquisition is in the ability to utilize far more of the returning echo information than is possible with beamforming systems. This animation demonstrates that of the 100% of the returning acoustic data set, about 90% is truncated, averaged, and ultimately dumped using traditional beamformer receiver technology. In a ZST system, on the other hand, nearly 90% of the acquired raw acoustic data is sent directly into channel domain memory, where proprietary software methods are used to create each image frame pixel by pixel. While premium high-quality diagnostic ultrasound imaging can certainly be accomplished with just 10% of the original acoustic data set, the capture and utilization of 90% permits faster image creation and more accurate temporal resolution in real time. For example, in this real-time clip of a fetal heart, spatial, contrast, and temporal resolution are all maintained throughout the cardiac cycle at all depths in the image. In fact, in this next slide, when the clip is reduced to composite still images, each frame remains in perfect focus from skin line to deepest depths because of advanced acoustic acquisition and the use of high-speed, high-capacity digital signal processing that are all hallmarks of zone sonography technology. Another characteristic or pillar of ZST is dynamic pixel focusing. Again, using 90% of the returning acoustic data set and employing advanced digital signal processing methods, each and every image frame is created pixel by pixel. Each frame is also continuously focused on both transmit and receive, resulting in an image that is perfectly focused from skin line to deepest depths without the need for operator to manually adjust the focal zone. Combined with synthetic aperture technology that is used in ZST, dynamic pixel focusing yields exquisite B mode and color Doppler images in resolution in all three planes, axial, lateral, and elevational, that is setting a new standard in the ultrasound imaging industry. Dynamic pixel focusing is demonstrated in this image of a soft tissue phantom. The image on the left was obtained using a traditional beamforming ultrasound platform with a single fixed focal zone. In the near field, the 1 millimeter pins are spatially resolved in both lateral and axial dimensions. As we move deeper into the image, lateral resolution begins to degrade, and the 1 millimeter pins begin to take on a splayed appearance until in the far field they are not recognizable as pins at all. Using zone sonography technology, the image on the right demonstrates how the integrity of spatial resolution is maintained throughout the depth of field. As one would expect, there is a slight splaying of the pins in the far field as the result of the normal ultrasound beam divergence. But overall, lateral resolution is significantly superior to that produced by the beamforming technology platform because every pixel is focused on both transmit and receive, every frame, every depth, every time. Dynamic pixel focusing also permits the use of higher fundamental and harmonic imaging frequencies to image at deeper depths. Traditional beamforming platforms require lower frequencies to image at depth. The trade-off with lower frequencies is, of course, reduced spatial resolution and an image that is comparatively suboptimal to one created with higher frequencies. The clinical benefits of dynamic pixel focusing include tightly focused 2D and color Doppler images, the ability to use higher frequency probes for improved image quality, the maintenance of superb detail resolution from skin line to deepest depths, and clinical confidence in imaging neonates to bariatric patients. The third pillar of zone sonography technology is automated sound speed compensation. Traditional ultrasound systems make the incorrect assumption that acoustic waves travel through human soft tissue at 1540 meters per second. In fact, that is an average value. In reality, the speed of sound propagation varies from between 1450 and 1650 meters per second based on the physical characteristics of the medium through which it is traveling. Sound speed compensation allows the operator, with a single button touch, to initiate a proprietary technological method that ultimately recalibrates the imaging system to reflect the true speed of sound in a particular organ or body part. This permits the more accurate spatial registration of individual echoes returning from various depths in the human body, increasing the spatial resolution throughout the field of view. Automated sound speed compensation begins with the acquisition of an acoustic data set from the human body. This data set is then sent to channel domain memory, where advanced software algorithms create a series of trial frames, each one constructed assuming a slightly different speed of sound. Smart onboard software then analyzes each trial frame and selects the frame with the best lateral resolution. The system is then recalibrated to this selected sound speed. Clinical benefits of sound speed compensation include improved spatial and contrast resolution in average and difficult patients, improved imaging at depth, improved imaging in dense organs, and improved imaging in diffusely diseased organs, such as fibroid uteri, multinodular goiters, and fibrotic livers. This clip clearly demonstrates the benefit of automated sound speed compensation. Real-time imaging through a moderately cirrhotic liver demonstrates suboptimal and frankly non-diagnostic image quality on the left, an image acquired without using sound speed compensation. On the right, with the use of sound speed compensation, hepatic tissue texture and discrete vascular structures are distinguishable clearly, while they are not on the left. The final pillar of zone sonography technology is total recall imaging, which permits retrospective image optimization and enhancement and analysis by storing the entire raw acoustic data set for subsequent reprocessing. The clinical benefits of total recall imaging include the ability to process and optimize images from archive, the elimination of repeat scanning, the ability to do patient-specific imaging, and the ability to store, retrieve, and off-board in-phase quadrature data for the use in acoustic advanced research applications. In summary, zone sonography technology is a proprietary, patented ultrasound image creation technology developed by Zonari Medical Systems in 1999. It is a constantly evolving software-based technology, or a living technology. Living technology is Zonari's approach to providing customers with regular and easily upgradable ultrasound enhancements based on the unique architecture and functionality of ZST. While conventionally created ultrasound images take about 10 times longer to create, that does not mean that the quality and clinical efficacy of these images are suboptimal. However, as zone sonography technology eliminates many of the conventional ultrasound imaging constraints, it opens up possibilities for new and exciting diagnostic applications. In all specialty areas, radiology, cardiology, pediatrics, vascular, obstetrics, women's health, and point-of-care markets, ZST offers exceptional imaging and technological capabilities that are moving diagnostic medical ultrasound into the future. Thank you.